Right, okay, so these two questions, question 1 and question 2, are really the same question. If you can remember the fetch execute cycle in general, then you will visit and meet all the registers. Okay? So I'm not asking you to memorize registers. What I'm asking you is to remember the process that the CPU goes through, that the control unit performs. And we will meet our friends. So let's have a look. So the first one where it all starts, the program counter, PC. So you get a mark for the acronym, and you get you get a mark for putting program counter. But for the third mark, the purpose, it holds, and don't say anything other than this, the address, which I'll shorten to that, of the next instruction. All right, it's all right. You can hear me. Of the next instruction to execute. That's all its purpose is. Remember, a register doesn't do anything. It is a storage location. So if you start saying it does this, it does that, no, it doesn't. It just holds a piece of information. So it holds the address of the next instruction to execute. Okay, so the next register that you're going to come across is the memory address register, because that's the one that we use to access memory. So the memory address register. Purpose, it's quite a dumb purpose. It's used to select a memory location for access. That's all it does. So that we can read or write from that location. So whatever value we put in the memory address register, that is the selected memory location that reads and writes operations. Okay, so assuming that we do a read, we fetch something from memory, we're going to come across the memory data register. The purpose of the memory data register, it just holds data that's arrived at the CPU. So when we do a read, this is where it appears. Remember, this is a generalized abstract model of a CPU, so there are other ways this can work, but this is just a generalization. And it also is the holding point for data that's going to leave. So holds data that's going to be written. To memory. Okay, so that's our first three registers. They're the ones that should just roll straight off your head. Okay, assuming we're at the start of the fetch execute cycle, we're going to assume that whatever we fetched and whatever arrived at the MDR is an instruction. So we will transfer it to the current instruction register. And its purpose is to hold the currently decoding and executing instruction. as its name suggests. They've all got pretty sensible names, to be honest. Okay, 2 more registers. Right, the general workhorse of the CPU, where we can hold temporary values and do calculations and hold the results of calculations, is the accumulator, which we always shorten to ACC because accumulator is a big word. So an accumulator is just a temporary storage location, holds results. Inside the arithmetic and logic unit. In general, most CPUs have got multiple accumulators of some description. Okay? Big old RISC CPUs that you get in your phones, they can have like 64 accumulators, which means you've got access to some ultra fast temporary storage. I'm always spelling calculations like that. My head gets ahead of me itself. Okay, the final register, and the crucial register that keeps track of results, is the status register. Status register, this is the register that allows us to make decisions, to do branch instructions, to respond to interrupts. So it has inside it now, so this just keeps track of the results of operations. So where we've had carry, overflow, negative values, interrupts have occurred. So some instructions that we execute might not necessarily be arithmetic, but they will set results in the status register. So when we compare 2 values, it's not really an arithmetic instruction, although underline when you're comparing, you're subtracting, but it does set registers, flags. So we've got the flags. You don't need, I'm saying don't need to remember, but I want you to remember. No bonus marks for this, but condition code flags. The N, Z, V and C. So negative, 0, overflow and carry are the main ones. There are others, depending on what CPU you're messing about with. You can have like half carry operations and all sorts of weird things. So you can tell whether you've carried from one nibble to the next, which is actually quite useful sometimes. Okay, so 18 potential marks there. Okay, the second question was the general 7 steps of the fetch execute cycle. Let's go for red for this. Step 1 is to transfer the PC to the memory address register because we want to get an instruction. Step 2 is to do a read operation. So from our main store at the location pointed to by the memory address register, we do a fetch and it arrives at the memory data register. Okay, the CPU, the control unit, decides that it must be an instruction no matter what because it's dumb. Okay, which is why it is fun to actually create images that are programs and things like that. Okay, so it says, right, okay, it must be an instruction. Let's whack it in the current instruction register. At this point, it will decode, works out what instruction it is. As soon as we've worked out what instruction it is and we know the format of the instruction and how much space in memory it took, we can increment our PC. And this is why it's important that when you describe the purpose of the PC, is that you don't say it holds the address of the currently executing instruction, which I see too many times. Because it doesn't anymore. We haven't even started executing this instruction yet, and it no longer points to it. Okay, step 6, a bit of a generalisation, execute. Okay, which may involve lots more fetching, depending on the instruction involved, but that is the general step. And then the final step, now that we've finished this whole instruction, is to check for interrupts, to see if we've got to go off and do something more important than this poxy program. 7 marks, assuming you got it in the right order. Right, the final question. The 3 components of a CPU. I'll do this in green for no reason other than I can easily. We have got the control units. You've got to remember the control unit is the one that's doing the fetch execute cycle. You have got arithmetic and logic unit, which is a right old mouthful. It's easy to put ALU, which is why we have acronyms. And the final, memory. Right, I'll let you have cache, but make sure you say cache memory. Okay, so that is the cache. It's the on-chip memory. Okay, it was out of 28. Will you top that up, ladies and gents? I'll start the recording.